Hi, Y10. Wanted to run through the solutions to the 2019 5.3 exam that only covers trig and logs, but you will have to do some of your own work on graphs of parabolas and straight lines. All right, first three multiple choice questions here. We've got a true bearing here, and the only thing we're given there is 50 degrees. Now, if we have a look at this, what we can see is that we know that this is 0, 90, 180, and 270. So my response straight away would be to go, all right, I know that I'm not A or B. And now I've just got to work out whether it's going to be 220 or 230. Where these two answers come from, one is if you go to 180 plus 50. And the other is if you go 180 plus 40, which is in fact the correct answer. You could also go 270 minus 50, and that would get you the same thing, 220 degrees. But C is our answer here. Now, to four significant figures means that we count the first four digits of our answer. So if we go put log of 38 in our calculator, of course, the 10 there is implied on your calculator. It's not on the button on your calculator, but that's what it means. Now, when I put that in my calculator, I get 1.579783. And what I'm looking for is the first four digits. Now, that would be easy to go and say B, but it's actually not B, because what this 7 does, the 7 pushes the 9 up by 1, which actually pushes this up by 1. So answer is in fact C, not B. That is just a calculator exercise. Answer D doesn't actually have four significant figures. It's only got 3 significant figures. And answer A is if you just ignore that 9 altogether, which is not correct. So question 3 here, we're asked to put that into logarithmic form. And we write log of our base, which is 2, our answer, which is 8, and our power, which is 3. So if I go looking for my answers here, I'm going to land on D. And again, that's just an expression that's already been evaluated for us. There's nothing we can actually solve there, but that is in logarithmic form. Next couple of questions here. The angle of depression here, we've got, we're trying to find this angle of depression, and we've got 75 meters and 1.2 kilometers. Now, in reality, our diagram probably looks something more like this. A very, very small angle of depression, because if we're going to 1.2 kilometers out to sea with a tower that's only 75 meters tall, it's a very different aspect ratio there. So answer D, I'm imagining, is gone. It's probably not D because I need a very small angle of elevation. So what I'm going to do here is I'm going to say tan of theta. Now, because we've got parallel lines, we can actually do our angle here as theta, or we could put our angle theta there and then take it away from 90 degrees. But our angle of elevation or depression is the one we are looking for. And because of parallel lines, we can find that angle at the bottom, the angle of elevation too, which is equal to our opposite 75 over our adjacent, which is 1200. Can't go and put 1.2 in there. You've got to put 1200. Now what that gives me, when I go and take the inverse there, is I get 3.576 degrees, which gives me approximately 4 degrees, which is B. Very small angle of elevation or depression here, as we are expecting. Our exact value of cosine 30. Now, I would go to my reference sheet and I would have a look at this exact value triangle, but I'm going to draw it here. I've got 60, 30, 2, 1, and root 3. You don't need to remember that. That is given to you on your reference sheet. Now, what I'm looking for is the exact value of cosine 30. So I'm going to go to 30 and I'm going to say, well, that is my adjacent, root 3 over my hypotenuse 2, and my answer is D. Okay, you can get there using your calculator as well by checking, but that won't give you your exact value. That will just give you the approximated value. All right, we're looking for an obtuse angle here. So that gives me negative tan 56. Well, the reason this happens here, we've got our all stations to central. And we know that in this quadrant here, an obtuse angle, 10 is negative. So that's where that negative value comes from. Now, my 56 degrees is over here, approximately. To get into quadrant 2, I have to say 180 minus 56, which is going to give me 124 degrees. So what we can then say is that we could reverse this as well. We could go tan 56 is equal to minus tan 124, or the other way around. But 124 and 56 add up to 180 degrees, which is what we're looking for here. Another question on logarithms where I'm asked to rewrite something this time in index form from log form. So I've got log 4 of 2 equals 0.5. Now the way I can rewrite that is my base is 4, my answer is 2, and my power is 0.5. The other way to rewrite that would be turning that 0.5 power, that half power, into a square root, which would give me root 4 equals 2, which again, like the earlier question, there's nothing to really solve there. You're just rewriting the form here. So I end up with 4. I believe answer D is missing from here, but answer D would have been the correct one here. 4 to the half is equal to 2. So that is your answer there. I'm imagining that was D, but it's just dropped off when I photocopied it. Actually, there's answer D. It's appeared at the top of the next page, so that would have been our answer to question 7 there. I've got 50 times 1.4 to the x equals 100. Well, the first thing I'm going to do is say 1.4 to the x. 1.4 to the x equals 2 by dividing both sides there by 50. Now I'm going to my calculator. I'm seeing that I've got a base of 1.4 and an answer of 2. I'm thinking my power is not going to be a nice one, so I'm going to turn that into a change of base rule. Log of answer 2 over log of base 1.4. Now, I'm going to knock out answer C and D here, because if I look at this and go, well, if I had a negative power for either of those, that would mean my answer would actually get smaller, get much smaller, and that doesn't happen. My answer here gets a little bit bigger. I'm thinking my answer is A, but let's check our calculator. And in fact, I was incorrect. Going to my calculator here, B is our answer. And that's just using our change of base rule. So which expression is not equal to log 3 of 27? So this is our log laws here. So I look at a couple of things here. I've got a division. Okay, so a division means I could rewrite this as log 3 of 1 minus log 3 of 27. Okay, so that's one way I could rewrite this, but then I could also say, well, log 3 of 1 is 0, so I could write that as minus log 3 of 27. All right, so C is a possible answer. So I'm going to eliminate that because it is a possible answer. Now, what I could do with that is say, well, what could I do with 27? Well, 27 is 3 to the power of 3, which means I could throw this out the front. I've got minus 3 log 3 of 3. Well, this expression here is equal to 1, so I'll eliminate that. So it could also be rewritten as minus 3. So again, D is a possible answer, so it's not an answer, if you'd like. And the first option here, really, either A or B is going to be incorrect, because they're my two options for change of base. Now, if I look at this here, my log is written in the form log base of answer, okay, BAP form. And if I go and look at that, to rewrite that as a change of base, I would go log 10 of answer, which is 1 over 27, divided by log 10 of my base, which is 3. And in fact, that means that A is correct. It's written as a division instead of a fraction, which doesn't particularly matter. But A is correct, and B has the answer and base the wrong way round. So B is, I'll cross that out, sorry. So B is in fact the thing that's not equivalent to that expression. So therefore, that's our answer we are looking for. All right, question 10 here is a change of base question, but it's done a little bit differently. It's done a little bit cheekily, if you'd like. Basically, what we can do, my change of base, I can rewrite this way. It's log of 3 over log of 2.5. Now, normally we use log 10 in our calculator, but technically we could use log anything. We just have log 10 on our calculator, so we use that. So our answer here is, in fact, D. But it's just rewritten with the base of 5, which is absolutely fine. It's just not going to be helpful for us with the technology we have available to us. If you were to use a higher end calculator to find log 5 of 3 over log 5 of 2.5, it'll give you the same thing as log 10 of 3 over log 10 of 2.5. The other ones are not correct because they don't take into account our log laws correctly. So that's our multiple choice questions. Let's go have a look at the written questions. Got to find our unknowns here. Our first is I'm going to say I've got cosine of theta equals adjacent 4 over hypotenuse 8. Theta gives me 60 degrees. It's an exact value there. You can go to your calculator and use the inverse if you would like. Next, I'm looking at sine 70 equals x over 6. So x equals 6 sine 70 gives me approximately 5.64. Do we have a unit? No, we don't have a unit for either of those ones. Well, for the length, we don't. Having a look at our next question. Consider the angle here of 195 degrees. In which quadrant does it lie? Well, it lies beyond 180 degrees, but not yet at 270 degrees. So that means I'm in quadrant 3. Now, for our next question here, which of our trigonometric ratios are positive for this value of theta? If I go have a look here at all stations to central, it tells me that I'm in quadrant 3 down here, which means tan of 195 is going to be greater than 0. But sine of 195 and cosine of 195 would be negative there. And you can check that in your calculator as well. Now, state the reference angle in the first quadrant. This is where we're saying, well, I've got this angle 195 down here. That's a little bit exaggerated, perhaps. What would it be up here in the first quadrant? And I hope what you can see to get there is I need to take away a straight line, which means I'm going to say theta would be 195 minus 180, which is 15 degrees. So if part 4 here says write cos 195 using the reference angle, well, that means using the acute angle. So that means I'm going to need some expression for cosine of 15. Now, what we're really doing here is saying, would cosine 15 be positive or negative? Well, cosine 15 here would be, in fact, negative because we're in the quadrant where tan is positive, which means cosine would be negative. And you could check that in your calculator as well. You could check whether it's positive or negative, but really we don't want a value for this. We just want to write it as an expression, which is cosine 15. A ship travels due east for 9 and then a true bearing 120 for 7. So I'm going from here, I'm going east for 9. Then I'm going on a bearing of 120 degrees, which is approximately down here somewhere for 7. Let's get that information on there. I've got 9, I've got my 7. I've also got, if I look here, I can say that angle is 30 degrees there, which means that one's 60 degrees. And I know that's a right angle there. And I can go and turn that into a non-right angle triangle, or I could turn it into a right angle triangle by extending it out here. But if you'd like, red is the sort of things that I'm given in my information here. How far south is the ship from its starting point? We're asked how far south it is. Well, that's this distance here. I'm going to call it D for distance, not S for south, because that looks like a 5. Now, as I look at it here, I'm going to use this right angle triangle because that's nice and straightforward. And I'm going to say I've got sine of 30 equals my opposite, D, over my hypotenuse 7. D equals 7 sine 30. Sine 30 is an exact value, which is 3.5 kilometers. Now, how far east the ship is from its starting point? Well, I'm going to need to find this this distance. I'll call that E. So I can use Pythagoras' theorem, or I could go back to my trig, which I'm going to do. So I'm going to say cosine of 30 equals E over 7. So E equals 7 cosine 30, which is an exact value, but not a particularly nice one for us to use here. But in fact, my distance is going to be 9 plus 7 cosine 30, because you've got to remember that we've travelled the 9 kilometres east to start with, and then another however many kilometres east as we've gone on that bearing of 120 degrees. Now that's going to give me a distance of 15.06 kilometres to 2 decimal places as required. We can leave out those exact value questions there because they involve radians. You could be asked to do exact values in degrees, but won't be asked to do those in radians. We're going to cover those after our exams. Okay, a couple of exponential equations here to solve. I've left the first couple off there because they are more index law type problems. Still very doable. With the first one here, I'm just going to add and subtract my powers. And then here, I would turn that into 2 to the 2 x plus 1 and go and add my powers again because I'm multiplying, which is similar to what we end up doing in some of these harder exponential equations, but I'll leave those couple for now. I'll let you do them. Our first one here, it's really me writing 27 as a power of 3, which means x is 3. Next one, I want to write 32 as a power of 2, which is 2 to the power of 5. So I've got x minus 3 equals 5, and x equals 8 is my two answers there. You can do the first one using a change of base. You can be careful and do the second one using a change of base, but I would say rewriting the powers is the better way to do that. Our log expressions here, again, we're trying to do similar types of things where we apply our log laws, but also look to change our powers a little bit. I've got log 5 of 125. Well, I can rewrite 125 as 5 to the 3. That 3 can come around the front. And I've got log 5 of 5, which is 1. So my expression here is just 3 times 1, or 3. If I've got this expression here, I can write it as log 2 of 8 to the minus 1, meaning that minus 1 comes out the front. And then I can rewrite 8 as 2 to the power of 3. So I end up with minus log 2 of 2 to the 3. The 3 comes out the front this time, which means my whole expression is equal to minus 3. If you are struggling with that log law, you could do that as a change of base. Log of 1 over 8 divided by log of 2, which will give you the same answer. Couple of our log laws applied here. If I am subtracting my logarithmic expressions, I'm going to divide my answer part there. So I've got log 4 of 32 divided by 8, which is 4. I've got log 4 of 4, which is actually 1. So that's how I end up with my expression there. And our last one here, I've got log 10 of 4 times 5, because again, 4 times 25, because again, when I'm adding together my logs, I'm going to multiply those answers in there, which is going to give me log 10 of 100. I can write 100 as 10 to the power of 2, which means I bring that 2 out the front and I end up with just an expression that's equal to 2 log 10 of 10. And of course, log 10 of 10 is 1, so my answer is just a nice 2. Four really nice answers there using my log laws. The question here, I'm going to use my log laws to find a couple of values here without actually going and finding what x and y are. Don't go find what x and y are. Our first question here is going to involve our log law of division. So what here I'm going to have here is log 5 of y minus log 5 of x. Well, I can't take those any further, except that I know what log 5 of x and log 5 of y are. So I can say I've got 1.209 minus 0.683. Well, now I can just subtract those as decimals, which gives me 0.526. Along the similar line here, I've got log 5 of x, I'm actually going to split this up three ways. Log 5 of x plus log 5 of y. And that's me saying I've got x times y. If you were to go and say, oh, well, what about if I bring that 2 out the front? You can do that, but it's not 2y. It's just 2x because y only has a power of 1 in there. Be very careful with that one. But if you write it as 2 log 5 of x plus log 5 y, that's absolutely fine as well. So what I've got here is my 2 times 0.683 plus 1.209 gives me 2.575. A couple of logarithmic equations to solve here. By going and rewriting these ones in index form, I'm actually going to set myself up really well here for the first couple. For our first one, I've got a base of 5, an answer of x, and a power of 3. Again, I've got my expressions written in the form log BAP, BAP. Well, 5 to the power of 3 is just 125, so x is 125. Again, looking at things here, if I've got a base of x, an answer of 16, and a power of 4, well, something to the power of 4 gives me 16. That means x equals 2. You could take the square root twice, which is the same as taking the fourth root, or just think, well, what to the power of 4 is going to give me 16, and that's 2. Employ my log laws here first. I've got a little bit going on, but I've got to get everything so I've got one single expression in terms of log 10 of x. So I've got my right hand side here is equal to log 10 of 16 minus, I'm going to rewrite, I'm actually going to leave that 2 and move it to the back. You'll see why in a second. Minus, I'm going to bring that 4 up the top, and 2 to the power of 4 is 16. So minus log 10 of 16 plus 2. So what I'm actually left with here is those guys are going to go, just equally subtract each other. So I'm left with log 10 of x equals 2. Again, I'm going to rewrite that in index form. I've got a base of 10, an answer of x, and a power of 2, which means x is 100. I could have tried to rewrite 2 as a log, but I think that's a lot messier way to do this. Our couple of questions here where we're going to answer in decimal form. Our first one, I'm going to say I need to do a change of base. I know that 5 to the 1 is 5, 5 to the 2 is 25, 5 to the 3 is 125, so my answer is like 2 and a bit, which gives me an idea of what I'm looking for. But to do that, I've got to say log of 52 over log of 5. Which gives me approximately 2.46 to 2 decimal places, which makes sense, right? I said it was 2 and a little bit. About 2.5 is going to take me from past 25, but not yet up to 125. Same thing here with our next one. I can rewrite that as a change of base as well, where I've got my expression written in log BAP form, BAP form. So I write that as log of 24 over log of 3. And again, that's 10 on my log 10 on my calculator. Once again, if I stop and think about that, all right, 3 to the power of what gives me 24? Okay, well, 3 to the power of 2 gives me 9. 3 to the power of 3 gives me 27. So I'm expecting, again, coincidentally, about 2 and a bit. I end up here with 2.89 to 2 decimal places. Our very last question in our exam here is identify the mistake. Okay, so our question here is log 7 to the x equals 350. And this is our very first error here. There may be others that follow on, but straight away, my log should be written in, if I've got base to the power equals answer, my logarithmic form of that should be log of base answer equals power. This person here has got it the wrong way around and said log of answer of the base. So my expression should read, in fact, 7 to the x equals 350. I could rewrite that as log 7 of 350 in 7 being the base, 350 being the answer, x being the power. And then I could go do my change of base. X equals log 10 of 350 over log 10 of 7. Now, in fact, you could actually skip line 2 altogether and just go straight to line 3. This person has still made a mistake on line 3, as in these two things should be switched. 350 should be on the top and 7 should be on the bottom. And you'll end up with your answer where x is about 3.001 to 3 decimal places, following suit from the previous question. And if we went and rewrote this, I know that 7 to the power of 3 is 243. So I'm looking for just a tiny little bit more than that, which is how I get 3.001. And I know that's correct. If I went 7 to the power of 0.332, my answer is actually going to be less than 7. So it's going to get smaller, and that's not what I want. I want it to get much bigger. Hope you've been able to have a good go at some of these questions. If you need any more clarification, please jump in and ask.